So thank you, Raheem. We have some interesting, almost quantitative results. We have a relative time for the flame to extinguish in the two different sized beakers. And in the second experiment, we saw that water got sucked up into the beaker. So we'll have to try to explain these. And what's interesting here, or kind of emblematic of science, is that when we're going after big questions like what is fire, rarely in science is there some experiment which just shouts out the answer to us humans. Here too, this is just data. It's just something, just a thing we tried. We tried to burn flames in different sized beakers. And how can we use this to the best that we can, using some logic, some inference, some deduction? How can we use this to build up a theory of fire? This is basically what science is. So I'm going to read from the platform. We are on the 1B landing. It's 1680, so we're a few years later. And in this little story, Johann Becher actually comes out of retirement back to Stahl's lab. So, welcome back, old friend. Stahl embraces his former mentor and teacher, the great Johann Becher. He welcomes back to the lab where they proclaimed to the world an explanation for fire. It is a substance that exists inside wood, wax, paper, and even metals, and is released as phlogiston upon burning. I'm thrilled you every turn. Not a day goes by where I don't smile fondly, remembering our revolutionary work, resolving some of the biggest questions in science. How does it feel to be back in the lab after 20 years? So enough of this. Becher cuts Stahl off. Although cranky and impatient, he lets a small grin escape. He doesn't want any of the small introductory talk. He just wants to get right into business. And truthfully, he's actually really gratified to be back in the lab. To him, retirement is kind of boring. So he's kind of pumped to be back. So tell me your theories. This is what I came for, and be quick about it since I don't have much time. Becher adds, poking fun at his own aging self. Tell me how you further developed our chemical theory of phlogiston. Yes, sir. So I burned candles in different sized glasses, just like all of you did, and like Raheem did, and obtained some interesting results. So imagine you were doing this, and this is basically the way the QuantumCamp is designed, is so you can imagine that you're the first scientist to do this. Like, what would you say? What did you say to explain the results that you got? So this is Becher, and this is Stahl, kind of conveying his theories. Yes, so I burned candles in different sized glasses and obtained some interesting results. Putting fire into a closed container, brilliant. Stahl's kind of making fun of Becher's kind of making fun of Stahl right now. I heard about your near-death accident. Wonder if your lab experiment idea had anything to do with that. Stahl is not ready to recount that horrifying moment in his lab when he almost passed out and died from asphyxiation. I'd rather not discuss. Respectfully, I would rather forget about that incident and just proceed to the science. So here's the two findings. Large beakers, as you know, allow a flame to burn longer, and after a candle burns, the air in the inverted beaker seems to pull water up into it. Stahl waits anxiously to see what his old mentor has to say about these results. Becher sits with his eyes closed for a moment, then suddenly, kind of mysteriously, without saying a word, struggles to his feet, hobbles over to a shelf, and grasps a dirty old sponge. And Stahl says to himself, why would this man grab a sponge? I'm not sure where he's going with this. So Becher sits back down and begins. If phlogiston is released from burning substances, perhaps it is itself a special invisible air. And this phlogiston air fills the ordinary air around it like a sponge, like water into a sponge. And like a sponge, there's a point when it's saturated. And so maybe the air, like a sponge, gets saturated with this phlogiston. And at this point, phlogiston can no longer exit the material, and the reaction stops, the fire stops. And this explanation fits with your first result. And Stahl adds, now seeing where Becher's going. And of course, we would predict that a large beaker is like a larger sponge. So if both candles burn at the same rate, and both candles produce the same amount of phlogiston, then the candle in the smaller beaker will fill its smaller air sponge in a shorter time and go out quicker. And so almost in unison, they're vibing off each other right now. They both proclaim, then the air all around us, the entire atmosphere, then might just be one enormous sponge willing to accept all the phlogiston we throw at it. But wait, Stahl interjects. Still a problem. How do we explain our results from the second experiment where the water was drawn up into the beaker? the air seems to disappear. So where is the flight going in this experiment? Becher and Stahl exchange bewildered glances. I'm sure there's a good explanation Becher cuts in. Let's take this up some other time. And actually, this is true. Becher and later chemists of the 1700s shrugged this observation off. There was no explanation. And even today, there's a bit of debate on this phenomenon. So curious what you think. To them, it remained a curiosity that could be ignored. If the brightest minds of the time ignored it, can we ignore something like this? Well, the only thing we can do is proceed with more experiments, take some more data, and see if we can come up with some more ideas.